Hi all, in the module again, we are again discussing the wireless fundamental concept is sectoring. Why we wanted to go for sectoring in the cell structure. Let us have a discussion here. So actually, basically a cell sectoring is nothing but a single omnidirectional antenna at base station is in the base station there will be a single omnidirectional antenna. That antenna is covered total 360-degree. So we are going to replace this omnidirectional antenna into several directional antenna. Okay, and this directional antenna will radiating with a specified sector. So why we need to go for the cell sectoring? That is nothing but to decrease the co-channel interference. Already in the previous session, we discussed about different types of interference which will affect the wireless communication systems: adjacent channel interference, co-channel interference, other channel interference, fading, all those things. So in order to reduce the or decrease the level of co-channel interference and increase the system performance, we are going for the sectoring technique. So, and also we can say one way to increase the subscriber capacity of a cellular network. Okay, subscriber capacity of a cellular network. And you see here, actually no capacity will be lost from the sectoring because each sector can reuse time and code slot, so that each sector will has the same nominal capacity. Okay, and also it will provide the interference reduction. Signal to interference ratio will be increases. Then next we will see about the how sectoring is going to be done in 3 sector cell as well as the 6 sector cells. Okay, when you assume that when 120-degree sectorization is used. Okay, so we know each cell we are placing omnidirectional antenna. In sectoring purpose, what we are going to do, we are placing a number of directional antenna. Okay, so here suppose we assume that 120-degree sectorization is going to be done. That is, one cell usually covers 360-degree, right? And this is divided into 3 regions. So if you see the diagrammatic in 3 sector cells, we divided this into 3. It is 1, 2, 3. Therefore we can place a 120-degree each. So 120-degree into 3 is nothing but 360-degree. For example, if you assume that when 60-degree sectorization is used, so what will happen? As usual, we are using a one cell consists of covers a 360-degree, but now if it is a 60-degree sectorization, we can divide this into 3 120-degree region. So now sectored regions are called as cell sectors. And sectoring is an effective and practical approach to the other co-channel interference problem. Okay, so here sectoring will increases the number of antenna to base station and it reduces the trunking efficiency. So now in the diagram we have seen how the sectoring has taken place. As the number of sectors per cell increases, no, the signal to interference ratio also increases, capacity of cellular system is also increases. Now LTE requirements, long-term evolution requirements is for only for the high data rate and spectral efficiency. Okay, hence we are having high signal to interference noise ratio. That is, we can say it will go beyond the 3G system. So to approach to this problem, that why we wanted to go for this approach. Okay, this approach is to that is nothing but we can say that supports the advanced signal processing at the receiver as well as the transmitter. And also the network level approaching like cooperative scheduling or encoding and multi-cell power control and distributed antenna. For these all things that LTE requirements will be, our LTE system is going to be support. And this approach will effectively reduce the other cell interference through the techniques called macro diversity and the efficient sharing of the system. Okay, so these all are the approaches is there. But if you go for advantage disadvantage, advantages will be more effective, and it can solve the OCI this other co-channel interference problem, sorry, other channel interference problem. And also antenna technique will, which we have given in the cell list, will increase the system capacity. But coming to the drawback, that is also very important. Since we are increasing the number of antenna at each base station, what it will have, implementation cost is increases, and the number of handoff is also increases. For example, in a cell 10 base station is there, 10 base station is having 100 calls, and the 100 calls in that 80 are need to hand off. That is little bit tough situation to face that. That is one of the drawback. And followed by that drawback, and also it will reduce the trunking efficiency. And due to the reduction in trunking efficiency, the next drawback is nothing but it increases the overhead of handoffs, as already we have seen, and also intersector interference. So these type of things will cause the power loss. So these are the drawbacks we are going to face in the sectoring. So as already I approach the new approaches to the other cell, already I have briefed, that is nothing but adaptive cooperative scheduling or encoding across the base station. And we can also adapt the multi-cell power control in the distributed antenna technique. So this is the things about the sectoring. There is a very good advantage as well as the drawbacks is also there. Hope everyone has understood this concept, cell sectoring, which we are going to use in the wireless communication, also in our LTE approach. Thank you.